Hello, this is Maraj Patel, and today we're going to be finishing up Unit 2 by talking about molar mass and how to convert molar mass to grams in for particular substances. So the first PowerPoint is about molar mass and how to calculate it. And first, before we start, the definition of a molar mass is a mass of 1 mole of particles, and molar mass is measured in grams per mole. And so molar mass is pretty much how much 1 mole of one substance weighs, and a mole is 6.02 times 10 to a third particles, and we want to figure out how much a mole weighs for each substances, and it changes. And so this picture shows moles of different substances, but notice how a mole of carbon and a mole of sulfur has a different volume, and also they weigh differently. See how carbon weighs 12.01 grams, 1 mole of carbon, but 1 mole of sulfur is 32.07. And so it's important to know that moles of the different substances weigh different amounts and they take up different volumes. So to calculate molar mass, we're gonna first start with the example with water. So before we start, we have to figure out how much of each particle we have. So in H2O, we have 2 hydrogens because the little subscript tells us the number of atoms for the element before it, and we have 1 oxygen. So that's how we got this. Then, once we know the number of each element, we go to the periodic table, and next to each element or underneath it says the atomic mass, which is usually like a decimal, and for hydrogen it's 1.01, so 2 times 1.01, that's how we get the molar mass of these 2 hydrogens. And then we find the atomic number for oxygen and multiply by its corresponding coefficient. So we have 1 oxygen, so we multiply 1 times oxygen's atomic mass, which is 15.99, or you can round it to 16. And we add up, like I said, these are from the periodic table, and these are the atomic masses of the corresponding elements. Then we just multiply these two products. So in my calculator, I'm doing 2 times 1.01 plus 16 equals, and we get 18.02 grams per mole, and this is molar mass, so it always has to be grams per mole. So here's example 2. Find the molar mass of glucose, which is C6H12O6. And first we figure out the number of each element, the number of atoms in each particle. So there's 6 carbon, because this little subscript tells us. There's 12 hydrogens, and there's 6 oxygens. So we have this here. Then we go to the periodic table, find the corresponding atomic mass. So for carbon it's 12.01. And with the atomic mass, we just multiply by the number of atoms we have in this particle. So we have 6 of carbon. So it'd be 6 times 12.01. And then we do that with everything else. So hydrogen's atomic mass from the periodic table is 1.01. And we multiply it by 12 because there's 12 hydrogens. And then the last element is oxygen. So oxygen's atomic mass is about 16. And we multiply by 6 to get this mass here. So we add up all these products, and 6 times 12.01 plus 12 times 1.01 plus 6 times 16 equals 180.18 grams per mole. And example 3, find the molar mass of aluminum hydroxide, AlOH3, and OH is with the 3. So for this one, it's a little tricky here because we have this parentheses, but it's the same way. We first figure out how much of each element we have. So aluminum, there's only one particles, and for oxygen and hydrogen, this 3 gets distributed, so this is sort of like math. When we have a number outside the parentheses, there's 3 of this single part, so there's technically 3 oxygen, 3 hydrogen. And so that's how we got that. Then we find the atomic mass of each element and multiply by the corresponding coefficient. So there's one aluminum, so aluminum's atomic mass is 26.98, and we multiply that by 1 because there's only one aluminum. And then there's 3 oxygens, so 3 times oxygen's atomic mass, which is 16, and then 3 times hydrogen's atomic mass, which is 1.01. So we add up these products, so 26.98 times 1, which is the same thing, plus 3 times 16, plus 3 times 1.01 equals 78.01 grams per mole. And that is how we do this problem. And here's a quick quiz to see what we learned. 1 mole of hydrogen gas, H2, contains 6.02 times 10 to the 23rd what? Molecules, atoms, moles, or grams? Well, 1 mole of hydrogen gas, but remember this is H2, so this is not an atom. This technically is a molecule, so it can't be atoms because if it was individual hydrogen, it would be atoms, but 6.02 times 10 to the 23rd times 10 to the 23rd, is 1 mole, and so if we have H2 times 6.02 times 10 to the 23rd, it would be molecules because H2 is a molecule. It's not an atom, and then this is a mole. So it's not 6.02 times 10 to the 23rd moles, it's just 1 mole. And grams, you can just eliminate that because we're not even talking about mass yet. And what is the molar mass of fluorine? So A says 6.02 times 10 to the 23rd moles. B is 19 grams, C is 19 grams per mole, and D is 6.02 times 10 to the 23rd atoms. You can eliminate A and D because they just describe a mole. And so you have B and C, and so when we talked about this, molar mass is always measured in grams per mole, and so the answer must be C. And FYI, we get 19 from the periodic table, so 19 is the atomic mass of fluorine. And that's how we got 19 grams per mole. Then here's the third problem. Calculate the molar mass of ammonia, which is NH3. So like we did with other problems, we first figure out how much of each element we have. We have 1 nitrogen and 3 hydrogens because it's subscript. Tells us that. Then we multiply the coefficient of each element times the element's corresponding atomic mass, which we get from the periodic table. So nitrogen is 14.01, so 1 times 14.01 gives you this. And then 3 times hydrogen's atomic mass, which is 1.01, so 3 times 1.01, and we add up these two products and get 17.04 grams per mole, and the answer would be B. And here's one more problem. What is the molar mass of ammonium sulfate? So here's a chemical formula for ammonium sulfate. So we have NH4 and then quantity times 2 and then SO4. And so because we have these parentheses, we have to distribute this 2. So we have 2 nitrogens, and 2 times 4 is 8, so we have 8 hydrogens. And we only have 1 sulfur and 4 oxygens. Because there's no parentheses, we don't distribute this 4. We just leave it with the oxygen. And this is what we got. So again, we look at the periodic table for the elements corresponding atomic mass. Nitrogen has atomic mass of 14.01, so 2 times 14.01, and then plus hydrogen's atomic mass, which is 1.01 times 8. Then we do sulfur, which is times 1, so you can just put 32.01 from the periodic table again, atomic mass. And lastly, we have oxygen here, which is atomic mass is 16.00, and we multiply that times 4, and we add up these products, and 2 times 14.01 plus 8 times 1.01 plus 32.01 plus 4 times 16 gives you 132.11 grams per mole, and the answer is supposed to be B, so ignore this. The answer is just B. And that is the end of this PowerPoint. So now we're going to go talk about molar conversions from moles to grams. And so again, this same picture shows us how moles have different masses for different elements, and they have different volumes. And so today we're going to be able to learn how, if 1 mole of Fe or iron is 55.85 grams per mole, how much does 2 moles weigh, or how much does 3 moles weigh, or how much does 0.0587 moles weigh. So we're going to figure out how to convert moles to grams using this conversion method. And so we get molar mass from the PowerPoint like we did with the last slide. We just figure out how much of each atom we have and multiply the molar mass of each atom times its corresponding number. And so this is a type 3 problem. So we learned how to convert from moles to atoms and atoms to moles, but now we're converting moles to grams and grams to moles, back and forth. And so this would be an example of a type 3 problem. So we have 2.5 moles, and we want to figure out how many grams there are if the molar mass is 16 grams per mole. So remember, when setting up these fractions, we put the numerator of the first fraction, we put the same unit on the denominator, so moles will cancel out, and we'll just be left with grams. And so whenever you're dealing with molar mass, there's always 1 mole and then X amount of grams, so in this case it's 16. So we just end up with 2.5 times 16. And the type 4 problem is grams to moles, just the opposite of this. And we start with grams, and we have to put grams on the denominator of the next fraction, so grams will cancel out. And whenever dealing with molar mass, you have 1 mole over X amount of grams, or X amount of grams over 1 mole. And so there's always 1 mole. That's how we get this. And the grams will cancel out, and we're just left with moles, which is what we want. So we do 24.02 divided by 12.01 and get 2 moles. And so here's our first problem. It's a type 3 problem. So we're going to be converting from moles to grams. And so aluminum satellite dishes resist corrosion because aluminum reacts with oxygen, forming a coating of aluminum oxide. And so what is the mass of 9.45 moles of Al2O3? So first, we have to figure out what we need. So we have moles, and we're going to convert to grams. And before we begin, we have to find the molar mass of Al2O3. So we figure out how much of each element we have. So we have 2 aluminums, 3 oxygens. And get this number from the atomic masses from the periodic table. So the atomic mass for aluminum is 26.98. So we multiply that by 2 because there's 2 aluminums, and add it with oxygen's atomic mass times the number of oxygens, and we get 101.96 grams per mole. So now we can convert because we have a molar mass right here. So we first write number of moles we have. So we have 9.45 moles, and we set up the next fraction, which is 1 mole at the bottom, because we need moles to cancel out, so we need whatever's in the numerator of the first fraction to be in the denominator of the second fraction. So we write 1 mole on the bottom, and then from the molar mass we know that 1 mole of aluminum oxide is 101.96 grams, so the gram amount goes on the top, and the reason why we put moles is so they cancel out. And we have 101.96 grams on top, so we just do 9.45 times 101.96 and get 964 grams is the mass of 9.45 moles of aluminum oxide. And so here's a second problem. So type 3 problem again, so converting from moles to grams. So find the mass in grams of 0.0452 moles of C20H42. So first we have to figure out what we need. So we need to go from moles to grams, and before we do that we need to find the molar mass of wax, which is C20H42. So we have 20 carbons and 42 hydrogens, and so we multiply the 20 times the atomic mass of carbon, because there's 20 of carbons, and 42 times atomic mass of hydrogen, which is 1.01, and we add these two products up and we get 282.62 grams per mole. Then we go to the conversion factor, and first we write the moles we have. So we have 0.0452 moles, and what goes on the bottom of the next fraction? Moles, because we have it on the numerator and we want them to cancel out so we can convert to grams. And so we write 1 mole on the bottom because this is molar mass, so there's always 1 mole. And the gram amount is from the molar mass right here. And before we do that, we cancel out the moles, and so we'll be in grams. And we write 282.62 grams on the top. And so we multiply 0.0452 times 282.62, and we get 12.8 grams. And here's a third problem, which is a type 4 problem. So this is the opposite, so we're converting from grams to moles. And this problem is when iron is exposed to air, it corrodes to form a red-brown rust, which is iron oxide, F2O3. How many moles are 92.2 grams of F2O3? So we have grams and we want to find out the number of moles. So first we have to find the atomic, or molar mass, of rust, which is iron oxide. And so that we have 2 iron and 3 oxygen. So we multiply 2 times the atomic mass of iron, which is 55.85. and add it with 3 times the atomic mass of oxygen, because there's 3 oxygens, and we get 159.7 grams per mole. So, and then now we can set up the conversion multiplication factor, and so we have 92.2 grams, and what goes on the numerator of the first fraction goes on the denominator of the next fraction. So we have to write grams on the bottom, and the grams is from the molar mass, so 159.7 grams goes on the bottom, so these grams will eventually cancel out and will just end up in moles. And so whenever you're dealing with the molar mass, how many moles goes with the gram amount? It's always 1, so we write 1 mole on the top, and so we just do, when we're multiplying this, we pretty much just do 92.2 divided by 159.7, and we get 0.577 moles in 92.2 grams of iron oxide. have one more problem. It's the same type of problem. Find the number of moles in 258 grams of dinitrogen monoxide. And so in this problem, they don't give us the chemical formula, but we can figure it out. So if you remember your Latin and Greek prefixes, di means two. So dinitrogen would mean two nitrogen, and mono is one, like a monorail, just one track. So monoxide is one oxygen, so it's N2O. And I forgot to mention this, but we have to first find out the molar mass, so we can convert from grams to moles. And so N2O3, so we have two nitrogens and one oxygen, so we multiply 2 times the atomic mass of nitrogen, which is 14.01, and 1 times 16 because there's atomic mass of oxygen because there's only one oxygen atom, and we get 44.02 grams per mole. So that's the molar mass, and we have 258 grams. So we first write that out for our conversion, and whatever goes on the numerator of the first fraction goes on the denominator of the next fraction. So grams will go on the bottom, and this is molar mass. So of this particular compound, so 44.02 grams goes on the bottom of the next fraction. So grams will cancel out, and we'll just end up with moles. And whenever we're doing molar mass, there's always one mole with an X amount of grams. In this case, it's 44.02 grams. So one mole goes on the top, and when we multiply this fraction, we just do 258 divided by 44.02, and we get 5.33 moles. So here's a quick quiz to see what we learned. So where do you look to get the molar mass of an element? A. Avogadro's number. B. The periodic table. C. Your neighbor's paper. Or D. Your face. Well, from after doing several problems, where did we look to get the atomic mass, or calculate the molar mass of an element, or a compound? We looked obviously at the periodic table. All these other answers are just so ridiculous. And so calculate the mass in grams of a sample containing 1.85 moles of water. Let's just do the problem first before we look at the answers. And so we have the molar mass of water. They just give it to us, 18.02. And we first start with 1.85 moles. And whatever we have on the numerator of the first fraction, we have to put on the denominator of the next fraction. So we multiply it times 1 mole because it's molar mass. So 1 mole always goes with the gram amount. And so moles will cancel. And on the numerator of the next fraction, we put the gram amount, which is 18.02 grams. And so moles will cancel out. And we pretty much do 1.85 times 18.02. 1.85 times 18.02, and we get 33.337 grams, and we can just round it up to 33.3, and the answer is B. So next question, calculate the number of moles in a spoonful of table salt, NaCl, having a mass of 13.5 grams. And so we first start out with grams, and before we begin, here's the molar mass of NaCl. And so we start with grams, so this is a typo, so just ignore this. So we start with 3.5 grams, so 3.5 grams, and grams is supposed to go on the bottom, so just ignore this part. So 3.5 grams, and we would divide it by 58.44 grams, and 1 mole goes on the top. So my bad, this typing I did this little part to show you. And so we do 3.5 divided by 58.44, and it would give you C 0.0599 moles. And pretty much again, we just did 3.5 grams divided by 58.44. Just ignore this little conversion. And that is the end of Unit 2. I hope that helped you, and if you have any questions, ask your chemistry teachers. The next unit, which is Unit 3, is going to be about modern atomic theory, and I hope you have a good day, and we'll see you later.